Hey, welcome everybody. My name is Chuck McCullough, and I'm going to be your host for today's episode on C++ programming. Today we're going to focus on functions. I'm going to give you a quick introduction to functions in this section, and we will continue in future episodes learning all about C++. Hey, if you haven't subscribed to the channel already, hit that subscribe button so that you're notified when we release new videos. We're constantly doing live streams as well as other produced videos to help you with your Java, your C#, and your C++ programming skills. Without any more delay, let's jump right in. In this section, we're going to discuss what functions are, the syntax of functions, how to call functions, how to declare or prototype functions. We'll also discuss parameters and return types. A function is just a named task, something that performs some calculation, that performs some task, and we give that a name and we encapsulate it in a certain place. We've already, in previous episodes, calculated the area of a rectangle. That is a computation that we might do in many different places in our application. So that might be something that we want to encapsulate and just give it a name, like get area of rectangle. If we provide the function with the width and height of the rectangle, it can return the area of the rectangle. As you can see with this function, that's exactly what we're doing. Let's break that down, though, and look at the different pieces of this function declaration. First of all, every function must define a return type. What kind of data, if any, is being returned from the function? The return type is required. If your function, though, doesn't return a piece of information as a result, instead it just performs some action, we will specify the return type as void. Next in the function's declaration is the name of the function. The name is also required. The function's name can be any combination of letters, numbers, and underscores. Starting with a letter and underscore, though, you can't start with a number in the name of the function. And the name should be a verb or verb phrase, and it should describe what the function does and not how it does it. So we would name this function get area of rectangle, or compute area of rectangle, or compute area, etc. Those are all good names. What we wouldn't want to name this function is multiply width times height and return the result. That describes how the function performs its task, and that's not the goal. I know this is very simple, but assume that in a more complicated scenario, that other programmers really don't know what the formula for calculating the area of something is. Rectangles are easy, but there are other parallelograms and tetrahedrons and all kinds of things that have more complex formulas. I don't want to know how you do it. I just want the answer. So the name of the function indicates what we're going to get as a result. Notice that this function returns the width times the height. Next in the parameters definition is the parameter list. After the function name, always an open and a closed parentheses, always a set of parentheses, even if there are 0 parameters for the function. The parameters are declared just like any other variable, type followed by the variable's name, and they are listed in a comma-separated list. There's really no limit to the number of parameters that can be passed into a function, as far as C++ is concerned anyway. Definitely might be a limit on how much a human could really understand about parameters. Typically, 2 or 3 or 4 parameters. Occasionally, we'll see functions that have 5 or 6, but 0, 1, 2, 3 is much, much more common. After the parameter list is the function's body, the actual algorithm, the task that needs to be performed, and that body is enclosed in curly braces. Inside the body of that function is just like the code we've already written in our course. We can declare local variables, and we can perform any number of statements. If your function has a return type, however, your function does need to contain a return keyword. So for functions that return a piece of information, every code path, so if you have if then else's and stuff, every possible exit from the function needs to have a return keyword that returns the data that you promised you would return. This function promises to return a double, and so when calculating width times height, double times double gives us a double result, and that's what we're returning from the function. Now, how do I call functions? Well, we call the function by using the name of the function, and again, parentheses, passing in the actual values. Here we're passing in 10 and 20. Notice that syntactically the declaration of the function, the definition of the function looks differently than the function call. When I call the function, I don't specify the data types of the parameters, and I don't specify that the function has a double return type. So syntactically, it's easy for me to tell the difference between calling the function, where actual values are being passed in, as opposed to the declaration of the function, where variable types are being specified. I must pass in the right number and the right types of arguments. Since the function expects 2 parameters, I must supply 2 parameters. The function returns a double, so if I want to snag the result and hold it in a variable, it must be a variable of type double as well. So the types all have to match. Doesn't have to be double, it could be some other data type like float or int, but this particular formula, we want double precision. Now, the function that we're calling must appear before the actual function call. So in our code, if I really looked at how this was implemented in main, the function getAreaOfRectangle appears before main. The compiler encounters the getAreaOfRectangle function before we call it. Then the compiler knows whether we're calling the function correctly or not, and can also knows how to put together the assembly language to actually make the function call. So the function has to be visible to the compiler prior to where we're actually calling it or using it. Now that may not seem very practical. So in a realistic sense, what we want to do is do a forward declaration. So instead of implementing the function and the function body prior to where we're calling it, we're going to implement what we call a prototype or forward declaration. Notice that the function ends with a semicolon rather than ending with the function body, the open and close curly brace. So what you see at the top is the forward declaration. What must appear somewhere else in our source code, and it doesn't have to be the same file, but somewhere else in our project would be the actual implementation of the function. And the function where we implement it, where we have the body, the curly braces, needs to match the forward declaration. So oftentimes we copy and paste. Anywhere in our code where we want to call or use the getAreaOfRectangle function, we need to have this forward declaration. And this forward declaration could effectively be duplicated dozens of times by all of the different source modules that are using or calling that function. But we need to make sure that we only have exactly one place in our application where the function is actually defined. So that will be somewhere else, and as I said, maybe in a separate file. In our next session, we'll talk about projects that contain multiple files, as well as the purpose of the .h file, the header file. Let's summarize real quick the different kinds of combinations of parameters and return types for our functions. A function, many functions do something, but they don't produce a result for the caller to look at. The Nike function, the just do it function, in this case, no parameters and no return. That function goes off and performs some task, It might prompt the user for information. It may just emit something to the console. It might update a database somewhere. It performs some task, but there's no result, and there's even no input parameters. The second case, our function do something, same thing, no return type, no result, but it requires some information from the caller. In this case, the caller is passing in a string, some text, and our do something function does something based on that text, but doesn't produce a result to the caller. It does return to the caller eventually, but it doesn't produce a result that they can grab and hold in a variable. Our last one, our calculate something, much like our calculate area function, has a return type. It does return a piece of information, and it does take parameters, a string and an int, parameter and p2. And so we have a bunch of lines of code that maybe does something with the parameter, the string, and then ultimately it does need to have a return statement so that it can return an integer result. If I multiply p2 times an integer, I get an integer result, and the caller can snag that if they wish. Hey, I hope you enjoyed today's session on functions. Now go out there and create some of your own functions. Maybe take some of those calculations for circles and rectangles from the last episode and convert those into functions, refactor them, make them into functions, and call those functions from inside your main code. Even some of the decision making that we had in the last episode, where we prompted the user for width and height and radius, maybe those could be functions as well. I'll let you explore that, and next week we will look at some possible solutions as well as organizing our source code into different source files. With that, I hope everybody has a great week. If you've got questions or comments or would like to see anything different, leave a comment in the comments below, and I'll see you next week.